Alright, now we're going to talk about angles in the coordinate plane. So all of our trig so far has probably just been with right triangles, so more of a geometry approach. Now we're going to look at angles in the coordinate plane. So it's kind of like we blend algebra and geometry together and we start putting angles on the xy axis. Alright, so first let's look at angle. What's that mean? Okay, so an angle is just what we know it is from geometry. The definition is two rays that meet at a point. Maybe not meet at a point, but share a common endpoint. So I kind of wrote that out as best as I could. So an angle has a ray there, and they meet at a point. Okay. Now that point that they meet is called the vertex. Now the initial side refers to an angle in standard position. So I guess we got to do these next three definitions kind of together. All right. So an angle in standard position has its vertex on the origin and the initial side on the positive part of the x-axis, and then the terminal side is just it could be anywhere else as long as the vertex is at the origin. All right. Now. That's what makes an angle in standard position. Initial side, just kind of like where you start. So it's like where you start counting the degree measure of the angle, and the terminal side is where it ends. So like a terminal in the airport is like the end of the airport. The terminal side of an angle is like where the angle ends. Okay, so if we look at this second picture, top of the page here, we see another angle in standard position. Okay, so now you might not always see that side drawn, but you always assume it's in standard position unless you have reason to be otherwise. And then this would be the terminal side. So there's different ways to measure the angle. You can measure a positive angle, a negative angle, or an angle bigger than 360 or less than 360. All right, so if this is 60 degrees right here, that could be considered a 60-degree angle. All right. That would be the positive angle. All right, positive angles go counterclockwise. All right, so if you know the positioning of the quadrants, like that's quadrant 1, quadrant 2, quadrant 3, quadrant 4, all right, positive angles go in that direction, like 1, 2, 3, 4. Okay, so if we went in the negative direction, starting at the terminal side and going this way, okay, then we can also say this is a negative 300-degree angle. Now, since negative 300 and 60 have the same terminal side, that is a coterminal angle. That's a pair of coterminal angles. Any two angles that share a terminal side. All right, so another coterminal angle could also be 420 degrees, because if you start on the initial side and go 360 and then 60 more, that would be 420 degrees. So 420, 60, and negative 300 are all coterminal because they share a terminal side. And then theta looks like a 0 with a belt. That's just a Greek letter that we use for unknown angles. So you might see x sometimes, you might see theta. Just know that it's just a symbol. Okay. And in this last picture here, we have another example of coterminal angles. So 60, 780, and negative 300 are all coterminal, and we'll talk about that more on the next page. Okay. So coterminal angles share terminal sides. So what I'd like you to do is, I'm going to delete this part because we didn't learn about radians yet, but if you did, you can certainly do that part. Anyway, I'm rambling. So for each angle, find two coterminal angles and write an expression for all coterminal angles. So if you want to try this on your own, go for it. If you want to see the first example and then try the second one on your own, go for it, but just pause when you feel it's appropriate. All right, so I'm going to do the first example on the left here. Find two coterminal angles for 320. So 320 implies we're starting at the terminal side and going in a positive direction. Okay. Now, if we started on the initial side, I meant to say that the last time, sorry. So it's on the initial side and go clockwise, that would be negative 40 degrees, because 320 and negative 40, 320 and 40 add up to 360. So one coterminal angle would be negative 40. Now, it's just like a fail-safe method of finding coterminal angles is either adding or subtracting 360. So that's where the negative 40 comes from. Okay, if I were to do 320, so we go around like this and then go around another 360, then we get 680 degrees. Alright, so that'd be another coterminal angle to 320. Alright, now to write an expression for all coterminal angles, we use this idea that we just add and subtract 360 to find coterminal angles. So the way to express that would be to take the original angle, alright, which would be negative 40 degrees, and then add 360, and we want to add any multiple of 360, but it has to be a full 360. So it could be you add 360, add 720, add 1080, alright, but you wouldn't add like 350 or 1 degree, alright? So to express that, we're going to do times n, where n belongs to the set of integers, okay? So you may have learned this notation in Algebra 2, or you may have not have. It's okay. You can write it out in words, but this symbol means belongs to. It's the Greek letter epsilon, and this is a boldface Z that is used to represent the set of integers. So that would be like 1, 2, 3, or 0, or -1, or -2. Pretty much that means, and you go in any direction, so we put dot, dot, dots. If you add any multiple of 360 to -40, like 2 times 360, or 4 times 360, or -10 times 360, and add it to -40, we'll get one of these coterminal angles. So that's how you express all coterminal angles. You take the original angle, and then add 360n, and make sure n is an integer. Alright, in the next video, I'll go over example 2, so if you want to try it on your own, do so before you watch the next video.